Welcome to A Level and EP Physics. In today's lesson, we will discuss past paper questions for EP Physics 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 4 says, a bus is initially traveling north at a constant speed as shown in the figure above. As the bus starts to make a left turn without changing speed, a passenger notices that a box on the floor starts sliding toward right side of the bus. Which of the following top views of the box, when correctly labeled, would best represent all of the horizontal forces exerted on the box as it starts sliding? So in this case, it is given to us the box starts sliding to the right. So it is sliding to the right. As the box is sliding to the right, there will be a horizontal force on the box, and horizontal force is only force of friction, and that horizontal force means the force of friction, it has to act to the left, mean opposite to direction of motion, because friction is opposing force. So this is direction of friction, and friction is opposing force, it opposes the motion. So simply we can write down friction opposes motion. Opposes motion in a very simple language you can understand. So if you understand this question, it is quite straightforward to answer this one. Box is sliding to the right, so the friction has to be to the left. So the answer for this question has to be B. For question number 5, we need to find out which block takes the longest time to reach the ground. If you look at given information for this question, it is given to us we have 3 identical blocks. Each take a different path from a height h to reach the ground. Block A is released from rest and falls vertically, mean it just falls vertically. Block B is released also from rest and slides down a frictionless inclined plane. Block C is projected horizontally with an initial speed v. So we need to find out which block will take the longest time. So if you look at block A, so this will cover this vertical displacement. So this will cover this vertical displacement, and this vertical displacement is equal to small h. Vertical displacement, so this is equal to h, and vertical displacement of block C, this is also equal to h. And so we can also write down small letter h here. Now we need to look at the vertical motion of A and C. So simply we can say vertical motion of A and C, vertical motion. So we are talking about A and C only. So we will compare these two blocks first of all. So if you look at initial vertical velocity of block C, vertical velocity of block C is 0 because this is projected horizontally. Initially it has no speed along vertical direction. So we can say initial vertical velocity for these two blocks is equal to 0, and vertical acceleration is equal to g in this case, because only force acting along vertical, that force is force of gravity. So in this case, height means the vertical displacement we have h. So this is the vertical displacement. So we can find out time taken from this point to the ground. So this time we need to calculate. As in this case, acceleration is constant, so simply we can use kinematic equations. S is equal to ut plus 1/2 at square. Initial vertical velocity is 0, so we can simply say h in this case will be equal to 0 plus 1/2 gt square. But one thing you need to understand is that in this case we are taking down is positive, so down is positive, so vertical displacement is positive and g is also positive. From here we can say that t is equal to 2h over g root of this. So as in this case, height of C and height of A is the same, and value of g acceleration is also the same, so they will take the same time. So we can say A and C, they will take same time. A and C, they will take same time to reach the ground. means they will hit the ground at the same time because the vertical motion is the same. Now, if you look at block B, for block B, we need to understand acceleration along this plane. And also you need to understand vertical displacement of A and C is shorter than the distance traveled by B. So we can say in this case, H is shorter than this distance, is shorter than distance traveled by B. So means B will travel longer distance. And now if you look at acceleration of B, we can figure out, imagine that this angle is theta. This angle is theta, so we can draw forces acting on this block. So we have one force, that is mg, and other force is the normal reaction force. We can say this is n. We can resolve this weight into components. So we can resolve this one into two components. So we have this component, this is mg sine of theta, and this component is acting along the plane because this angle is theta, this angle is also theta. So mg sine theta is acting down the plane, so we can say F net is equal to ma. This is the resultant force acting on the block along the plane because there is no friction. F net is equal to ma. In this case, F net is equal to mg sine of theta, and this is equal to ma. So from here we can cancel this m with this m. So value of a, this is equal to g sine of theta. G sine of theta. A is equal to G if angle is 90 degrees. But as angle is lower than 90 degrees, it means that A is lower than G. So in this case, you can see one thing, A is lower than G, means acceleration of block B, we can also write on sub B. And the second thing is that distance traveled by B is longer than height, means the vertical displacement of A and C. So it means B will take longer time. So time taken by B, it will be longer than time taken by A or time taken by C. So the answer for this question has to be B because question is asking you the longest time. So the longest time is taken by B. So the answer for this question is B. So this is how you need to answer. One thing you need to understand is that if you throw any object horizontally with any velocity, or if you just drop the object, if vertical displacement is the same, time taken will be the same if we ignore air resistance. Very important concept. So if this point is clear to you, it means your concept about projectile motion, means the basic understanding of projectile motion is clear. For question number 6, we need to find out which block has the greatest speed just before hitting the ground. This question is simply based on law of conservation of energy, or simply we can say in this case simply based on law of conservation of mechanical energy, because in this case there is no any other resistive force, means we are ignoring friction, we are also ignoring air resistance. So we can apply law of conservation of mechanical energy. For block A, if we apply for block A, simply we can write down for A. For A, initial energy is only potential energy, so this is mgh, and this one has to be equal to the final kinetic energy, 1/2 mv square. So this is for block A. In this case, our reference line, very important. So our reference line, or we can say reference level, is ground. At this point we are taking h is equal to 0, height is equal to 0. So all the potential energy will be converted into kinetic energy when the block just before hitting the ground. So this is for block A. For block B, we can also write down the loss in GPE of block B. This is equal to mgh because vertical height is the same, and gaining kinetic energy also will be equal to 1/2 mv square. So block A and block B, they will have the same speed. We can also write down speed from here v, so mass will be cancelled. This will be equal to 2gh, root of 2gh. And for block B, we can also write down v, this is equal to 2gh, root of this one. So block A and block B, they will have the same speed when they hit the ground. Now if you look at block C, for block C, initial energy, initial mechanical energy, this one has to be equal to final mechanical energy. Initial mechanical energy, it has initial speed, that is 1/2 m v naught square plus loss in GP, means it has initial GPE. This one has to be equal to final kinetic energy, because final GPE is equal to 0. So I'm not writing 0 here. So in this case, again we can cancel m with m. So this m will be cancelled. So in this case, v square, this will be equal to v naught square divided by 2 plus gh plus gh. And so this is v square divided by 2. Now we can write down in this case v square, this will be equal to v naught square plus 2gh. So we need to calculate v in this case. So v simply will be equal to v naught square plus 2gh, root of this one. So you can see in this case the speed of C. So this is speed of C, this is speed of A, and this is speed of B. So in this case it is very clear that VC is greater than VA and is also greater than VB, because this has this extra amount of speed. So C has the greatest speed. So the answer for this question is C. A beautiful question based on conservation of energy, and most of the time many students, they just ignore this initial speed, mean they just ignore this initial kinetic energy. Question number 7 says a ball is dropped from rest and falls to the floor. The initial gravitational potential energy of the ball earth floor system is 10 joules. The ball then bounces back to a height where the GPE is equal to 7 joules. What was the mechanical energy of the ball earth floor system the instant ball left the floor? So very simple question, just little bit tricky one. So the best way to answer this question is, we can first of all imagine this one is the ground. So this one is the floor, and the ball is dropped from certain height, and GPE of the ball at this point, this is equal to 10 joules. So this is the initial. Then it is given to us the ball hit the floor, and when just the instant ball left the floor, so we can imagine when the ball is here, the ball is here at this point, we need to find out what is the mechanical energy of the ball. And also it is given to us this ball bounces back to certain height, it bounces back to this height, and GPE of the ball at this point, means the GPE of the system, this is equal to 7 joule. So it bounces back to this height, and GPE at this height is equal to 7 joules. We need to find out what is mechanical energy at this point. So in this case we are taking ground as our reference level. So ground is reference level, means GPE here is equal to 0. So if GP is equal to 0, so at this point the mechanical energy of the ball, we can say ME, the mechanical energy of the ball, this is only equal to kinetic energy of the ball, because GPE of the ball is equal to 0. So let me write down here plus GPE at this point. So in this case GPE is equal to 0. So we can say the mechanical energy of the ball, this is only equal to kinetic energy of the ball. As in this case there is no air resistance, so when the ball will rise, its kinetic energy will be converted into GPE. So at this point we can say kinetic energy has to be equal to 7 joules. So the mechanical energy of the ball when it just leave the ground, mechanical energy has to be equal to 7 joules by conservation of mechanical energy. So here ball has kinetic energy, at this point kinetic energy will be converted into GPE. So the answer for this question has to be C. Question 8 says a disk is initially rotating counterclockwise around a fixed axis with angular speed omega naught. At time t is equal to 0, two forces shown in the figure are exerted on the disk. If counterclockwise is taken as positive, which of the following could show the angular velocity of the disk as a function of time? Mean how angular velocity is changing with time. So the first thing, simply we can say in this case counterclockwise we have to take positive. So initial angular velocity also has to be positive. So now if you look at given options, option A is incorrect because this is showing initial angular velocity is negative, and option B is also incorrect because this is also showing initial angular velocity is negative. So the answer is C, our answer is D. Now if you look at this given system, in this case the net torque is counterclockwise, so net torque is clockwise, so the net torque tau net, this one is clockwise because this force is bigger, so the net torque on this disk is clockwise. As net torque is clockwise, and we understand torque is equal to I times alpha, so tau net and alpha, they must have the same direction. So it means that in this case alpha, this is clockwise, and clockwise is negative, and clockwise is negative. So alpha, this is equal to delta omega over delta t, delta omega over t. It simply means that the gradient of omega against time graph, so if we take omega on y-axis, t on x-axis, the gradient of this one, gradient will be equal to alpha. So gradient of omega against time graph, this is equal to alpha, and alpha is negative, so the gradient has to be negative. As alpha is constant, so gradient also has to be constant. So we can say alpha is negative and alpha is constant because net torque is constant. So simply we can write down constant here. So the gradient of omega against time graph has to be, means the gradient has to be constant, gradient has to be constant, and gradient has to be negative, constant and negative. So option C is the best answer because this gradient is constant and this gradient is negative. So the answer for this question is C. So in this case, first of all, disk is rotating counterclockwise, but net torque is clockwise, so this disk will start slowing down, and finally omega will be 0, and then omega will be negative, means omega will be clockwise. So this feeling is also important. You need to understand what is happening. So at this point, after this period of time, omega will be 0. Before this one, omega is positive. After this, omega will be negative. But acceleration, means the rate of change of angular velocity, is constant. Question 9 says a 50 Newton box is at rest on a horizontal surface. The coefficient of static friction between the box and the surface is 0.50 and the coefficient of kinetic friction is 0.30. A horizontal force of 20 newtons is exerted on the box. The magnitude of acceleration of the box is most nearly. So we have to calculate magnitude of acceleration of the box. Means block has to move. So first of all, we can sketch. So simply we can sketch our block, and this block is placed on a horizontal surface. The weight of the block is 50 newtons, so we can draw the weight of the block. This is 50 newtons. So this is weight of the block, that is equal to 50 newtons. And normal reaction force on this block also has to be equal to 50 newtons. So this is normal reaction force because block is not accelerating vertically up and down. So normal reaction force is equal to 50 newtons. So first of all, we can find out in this case is the block is moving or not. In this case, it is given to us the force acting on this box to the right is 20 newtons. So this is the force acting on this. Now we can find out maximum force, means the limiting value of static friction, maximum value of static friction. We can say this is Fs. So Fs in this case will be equal to mu times n. So this is the maximum value of friction, limiting friction, maximum. So mu in this case we have that is equal to 0.5, and we have normal reaction force that is equal to 50. So if we solve this one, we will get 25 newtons. So the maximum value of static friction in this case is equal to 25 newtons, and 25 newtons is greater than 20. So it simply means that as Fs maximum, this is greater than 20 newtons, it means block will not move. Block will stay at rest, not move. As block will not move in this case, so it means acceleration of the block simply will be equal to 0 meter per second per second. So the answer for this question has to be A. So always check is the block is moving or not. So this is just a tricky question, so you have to solve this one. You have to check is the applied force greater than maximum value of friction or not, means the maximum value of static friction. If applied force is greater, block will move, block will accelerate, it means there will be resultant force, and then you can calculate acceleration using coefficient of kinetic friction. But in this case block is not moving, so acceleration is equal to 0 meters per second per second. Question 10 says a thin rod of length d on a frictionless surface is pivoted about one end as shown above and can rotate freely. The rod is at rest when it is struck by a sphere with linear momentum of magnitude pi perpendicular to the rod. The sphere rebounds along its original line of motion with momentum of magnitude pf. What is the magnitude of the angular momentum of the rod immediately after the collision? So in this case, first of all, we can write down angular momentum. Angular momentum is equal to r cross p. R, we can say this is equal to rp sine of theta, and theta is the angle between linear momentum and r. In this case theta is equal to 90 degree because it is given to us perpendicular to the rod, so theta is equal to 90 degrees. So simply we can say in this case angular momentum is equal to rp. R, we can say this is equal to mv times r. In this case r is equal to d, so we can say this is equal to mv times d. So we can also calculate change in angular momentum by simply writing that final linear momentum minus initial linear momentum times d for sphere. So we are talking about sphere here. So in this case the initial linear momentum, we can also look at angular momentum, but simply you can take the linear momentum. In this case angular momentum is counterclockwise, in this case angular momentum will be counterclockwise, and in this case angular momentum will be clockwise. So here we have angular momentum that is counterclockwise, here it is clockwise. So in this case we will take clockwise positive, or we will take linear momentum downward as positive, and this one we will take negative. So this one will be negative and this one will be positive. So now we can write down here, so this is pf minus into minus pi, so minus pi, and this is multiplied by d. So simply the change in magnitude of angular momentum, this is equal to pf plus pi times d. So this is the change in angular momentum of sphere. As in this collision, for this system total change in angular momentum has to be 0. So the change in angular momentum of this rod also has to be equal to pf plus pi times d. So this is for the rod. So change in magnitude of sphere, change in magnitude of angular momentum of sphere, this one has to be equal to change in magnitude of angular momentum of the rod, because in any collision angular momentum is conserved. So the answer for this question has to be D. Question 11 says a spacecraft is placed in a circular orbit around a planet with mass equal to 6.4 times 10 to 23 kgs. The spacecraft orbits at a height of 4.5 times 10 to 7 meters above the planet's surface. What additional information is needed to calculate the speed of the spacecraft in the orbit? So for this question, simply we need to calculate orbital speed. So v orbital, so we can say v orbitals, orbital speed, and orbital speed simply is equal to gm over r, or we can say gm over r, but this r is representing distance from the center of the planet to that point. So we can simply, this is root of gm over r. We can also derive this formula. You can simply use Newton's law of gravitation, g capital M small m over r square. This is equal to m v square divided by r. So this is small m. So we can cancel with this one. In this case 1r we can cancel with this. So v simply is equal to g capital M divided by r. So this is how you can calculate orbital speed. But you need to understand the meaning of this symbol. G is a universal gravitational constant, and this m is the mass of planet. So capital M is mass of planet. Mass of planet, and r is the distance from center of planet. So r is distance from center of planet. Center of planet is not the radius, from center of planet. So in this case simply we can sketch. We have this beautiful planet. So let's say the radius of this planet, this is equal to small r, and the satellite is orbiting, spacecraft is orbiting at this point. In the question we have this height. This height is given to us, so we can say this height is h, and this is given to us in the question. This height is given. Now we need to calculate the orbital speed of this spacecraft. So what do we need? So if we rewrite the formula, we will write on this is g times capital M divided by r plus h. So this is orbital speed, and in this case we have value of this. G is a constant. We have value of this as well. I mean, this height is given to us, that is equal to 4.5 times 10 to 7 meters, means height from the surface of the planet. So if we have value of r, we can calculate orbital speed. So simply we need planet radius. So we can say planet's radius we need if we need to calculate orbital speed. So the answer for this question has to be B.